Welcome to this tutorial where we will delve deep into the fascinating world of cryptocurrency by implementing a privacy coin wallet specifically for Monero or Zcash. My name is Your Name, and I'm excited to guide you through this journey of creating a secure cryptocurrency wallet. Privacy coins offer a higher level of anonymity than traditional cryptocurrencies, making them an exciting area of development. Before we jump into the code, let's discuss some prerequisites. Make sure you have a clear understanding of Java programming, as this tutorial will utilize Java for our wallet implementation. You'll also need to have tools like Java Development Kit, JDK, installed on your system, along with an integrated development environment, IDE, like IntelliJ IDEA or Eclipse. This tutorial is structured into several key sections. First, we will discuss the basic concepts of privacy coins and how they work. Next, we will set up our development environment. Following that, we will create a basic wallet structure, implement functionalities to generate wallet addresses, check balances, and send transactions. We will also touch upon securing private keys and ensuring user privacy. Let's start off with understanding what privacy coins are. Privacy coins like Monero and Zcash use advanced cryptographic techniques to hide transaction details such as sender, receiver, and the amount being transferred. Monero uses a protocol called ring signatures, while Zcash employs Zcash and ARKS for privacy. Understanding these concepts will aid in our wallet development. Now, let's set up our development environment. In this tutorial, we'll be using Maven for dependency management. Create a new Maven project in your IDE. Next, navigate to your project directory privacy wallet and open the pom.xml file. We need to add some dependencies that will be crucial for our wallet implementation, especially libraries for HTTP requests and JSON processing, like OKHTTP and JSON. With our dependencies set, let's create a basic structure for our wallet. Start by creating a new package called Wallet. Inside this package, create a class named Wallet. This will be the core class for managing our wallet functionalities. In this wallet class, we will define attributes like private key, public key, and address. We will also create methods for generating new wallet addresses. Let's implement the constructor and a method to generate a new address. To generate keys, we can utilize existing libraries or algorithms. For simplicity, we'll simulate key generation. However, bear in mind that key management is vital in a real application, so be sure to implement secure key generation methods using cryptographic libraries. Now that our wallet can generate keys, let's move on to implementing the functionality to check account balances. To interact with Monero or Zcash networks, we need to have access to their respective APIs. Let's implement the fetch balance from API method. You can typically get balance data by sending an HTTP GET request to the Blockchain Explorer API for Monero or Zcash. For Monero, a placeholder API endpoint would look something like http // your Monero node 18081/get_balance. Make sure to replace it with a valid address on your local node or a public API endpoint. The next key functionality we'll implement is sending transactions. This method will involve creating and broadcasting a transaction to the network, which includes the recipient's address and the amount to be sent. Here's how we can outline the send transaction method. Similar to balance checking, sending a transaction involves calling an API endpoint specific to Monero or Zcash. Ensure you have access to the node's API that will process the transaction. It's vital to securely manage your private keys. Let's take a moment to discuss the importance of storing private keys securely. For our wallet, consider using secured storage mechanisms such as key store or encrypting the private key before storage. To manage privacy, it's essential to anonymize your transactions. Monero automatically handles this for you. However, in Zcash, you can choose between transparent and shielded transactions. Make sure to include functionality that allows users to choose their desired privacy level when sending transactions. As we're building this wallet, it's important that we handle exceptions gracefully, especially during API calls. Implement proper error handling to notify users of any issues that may arise during wallet operations. Let's add a simple try-catch around our API calls. We now have a basic structure that allows us to create a wallet, check balances, and send transactions. This is just the starting point. You can extend the project by adding more robust security measures, a user interface, and integrating more features like transaction history. In the next segment, we will discuss how to securely back up your wallet. This is a crucial step, as losing access to your private key means losing access to your coins permanently. Implementing a robust backup mechanism is vital in crypto wallet development. Also, consider developing recovery mechanisms that allow users to recover lost wallets with seed phrases or similar methods. This increases user confidence in your wallet application, knowing they won't permanently lose their funds. Before we wrap up, let's touch upon testing. Testing is essential to ensure our wallet functions as intended and remains secure from potential vulnerabilities. Implement unit tests for each method and conduct thorough testing, especially for transaction-related functionalities. Incorporate user feedback into your development cycle to continuously improve your wallet application. Engaging with your users will help you understand their needs and priorities, enabling you to create an even better user experience. Now that we've approached the tutorial's end, remember that the world of cryptocurrency is continually evolving. Stay informed about new security practices and privacy features, as they can significantly impact how you develop and maintain your wallet. Thank you for joining me in this comprehensive tutorial on implementing a privacy coin wallet. I hope this has been informative and empowers you to create your own secure wallet. Don't forget to like, subscribe, and hit the notification bell for more exciting tutorials in the future. Stay tuned and happy coding!